in the increasing order of boiling points. NH3, PH3, ASH3, SBH3. They are called ammonia, phosphine, arsine, stibine, the hydrates of group 5 elements. So, the answer is actually this. PH3 less than, ASH3 less than, NH3 less than SBH3. Why is it like this? Boiling means converting a liquid to a gas, where you have to overcome the intermolecular forces. Suppose you have ammonia in liquid state, NH3, NH3, like this. Many molecules of ammonia in liquid state. You will have some intermolecular force between these two molecules. And actually, in the case of ammonia, the intermolecular force is hydrogen bond. Between two molecules of PH3 and PH3, PH3 is not an ionic compound. There is no ionic attraction. PH3 is no metal. There is no metallic bond. Therefore, in the absence of metallic bond, ionic bond, what you have to look at is, in the absence of metallic bond and ionic bond, I repeat, the intermolecular forces are either through hydrogen bond or van der Waals attraction. Once again, in the absence of metallic and ionic attractions, metals, it is metallic bond. Ionic compounds, it is their ionic attractions which are governed by lattice energy. So, in the absence of these two, if you don't have metallic and ionic bond, what you have to look at is either hydrogen bond or van der Waals attraction. And hydrogen bond is there only when FH, OH, NH bonds are present. I repeat, only when FH, OH, NH bond. So you should have nitrogen, oxygen, fluorine bonded to hydrogen. If you don't have any of these three, forget hydrogen bond. So in the absence of hydrogen bond, there is only van der Waals attraction, and van der Waals attraction is directly proportional to mass. But B1, when should you talk about van der Waals attraction? When you don't have metallic, ionic, hydrogen bond. When you don't have all these three, only then you should talk about van der Waals. In the absence of metallic, ionic, hydrogen only, you should talk about van der Waals, which is directly proportional to atomic mass or molecular mass. Therefore, PH3 has the least mass. Ammonia has got hydrogen bond. So, ammonia should have the highest boiling point. But in this particular set of elements, stibine has more van der Waals attraction than the hydrogen. The van der Waals attraction stibine is greater than the hydrogen bond in ammonia. Therefore, PH3, ASH3, ammonia comes only second in this list. Actually, when you look at some other list, as we do immediately after this, you will find it to be slightly different. So, I will take another set. This is one set whose answer we have got. And this question is pertaining to group 5A. So, as is our practice, we don't study 5A, 6A, 7A separately. You look at H2O, H2S, H2Se, H2T. So, these are the hydrates of group 6 elements, 6A. That is why we are studying all these three groups together. We can't learn boiling points of hydrates of 5A now and 6A some other time. So that's why all three groups together we are studying P block. That's the reason this is the heading. 5A, 6A, 7A. Who are they? H2O, H2S, H2SE, H2A. Oxygen, sulfur, selenium, tellurium belong actually to 6A. Nitrogen, phosphorus, arsenic, antimony, which we studied a few moments ago, is they belong to 5A. And we studied the hydrates NH3, PH3, ASH3, SbH3. It's not surprising they have the same formula, MH3 type, MH3 hydrates. All of them have a trivalency with respect to hydrogen. And look at this, it is H2O, H2S, H2Se, H2T. So what is clear here? Sixth group elements, they already have 6 electrons and they need 2 more electrons only. That's why they are divalent with respect to hydrogen, H2O, H2S. So, what about the boiling points of this? We have studied the boiling points of these 4 compounds. What about the boiling points? The rule is, in the absence of metallic bond, metallic, no. Do you have a metallic bond here? No. Do you have ionic bond here? No. So what is it you have? Hydrogen bond. Where do you have hydrogen bond? Hydrogen bond is there only when FH, OH and H bonds are there. I already told you that. So H2O is a special case with hydrogen bond. So if you ignore H2O, H2S, H2Se, H2T, you just forget H2O for the time being. I am talking about only these 3. H2O, H2S, H2Se, H2T, these 3 are not metals, these 3 don't have ionic bond, and once again these 3 don't have hydrogen bond. So what are we supposed to look at? In the absence of all these 3, you should talk about van der Waal, which is directly proportional to mass. Therefore, H2S is a lesser boiling point than H2SC than H2T. As you know well, top to bottom, atomic mass is increased. Tellurium is the heaviest, oxygen is the lightest. So for these 3 it is okay. But what about H2O? H2O tops the list. H2O, though it has very less mass, because of hydrogen bond. So if you look at mass, H2O would have been the least in the boiling point list. But we don't talk about mass when there is hydrogen bond. So this is the order. In the absence of metallic bond, ionic bond, hydrogen bond, we have to talk about van der Waal, which is directly proportional to mass. So H2O tops the list here. So you can apply the same logic to many more. Let us look at a few of them. HF, HCl, HBr, HI. HF, hydrogen fluoride, hydrogen bromide, hydrogen chloride, hydrogen iodide. These are not strictly hydrates. You have to call them hydrogen halides, hydrogen fluoride, hydrogen bromide. They are not halogen hydrides. They are not halogen hydrates. They are hydrogen halides. So here you are. Once again, metallic bond, metallic attractions don't exist. They are not ionic compounds. How do you know somebody is an ionic compound? For somebody to be ionic, there must be a metal. I never told you metals form ionic bonds only, but for the presence of ionic bond, the presence of a metal is a precondition. Therefore, they are not metals, they are not ionic compounds, and HF has hydrogen bond, FH bond, hydrogen bond. So in the absence of HF, once again, forget HF, just talk about HCl, HBr, HI. Just talk about these 3. When you talk about these 3 only, ignoring this HF which has a special bond called hydrogen bond, HCl, HBr, HI, the order is decided only by mass. HI is the heaviest, therefore the van der Waal attraction in HI is the biggest among these 3 only. But what about HF? HF, though it has little mass when compared to others, lesser mass when compared to others, it tops the list because of hydrogen bond. So that's it. And you just compare boiling points of helium, neon, argon, krypton, boiling points of. Here there is nothing to compare what exists between 2 atoms of helium. What exists between 2 atoms of helium? what is the intermolecular or interatomic force between two atoms of helium? You can't expect a hydrogen metallic bond, ionic bond. So only mass, only mass. You have only mass as a deciding factor. Therefore, helium less than, neon less than, argon less than krypton. And